Hello and welcome to the 15th edition of International Observe the Moon Night. This is a day each year that we invite everyone on Earth to observe the moon, learn about the moon, and celebrate the moon in our arts and culture. Hi, I'm James Tralie. I'm a producer at NASA Goddard.
Hi, I'm Andrea Jones, and I am the Public Engagement Lead of the Solar System Exploration Division here at NASA Goddard, and I'm also the Director of International Observe the Moon Night. So we are so excited that you are observing the moon right now. With about 1 million people around the world on all 7 continents, people are observing with you. We're so glad that you're here. And wherever you're joining us from, we'd love for you to show us where you are and how you are observing the moon. So you can share that with us and with people around the world using the hashtag Observe the Moon on your favorite social media platform. And you can share us photos with us through the Flickr group as well, linked through our website, moon.nasa.gov/observe. And there we have lots more program information and resources as well.
Yeah, so International Observe the Moon Night is an annual event that occurs usually in September or October when the moon is around the first quarter. This is a great phase for evening observing with dramatic shadows along the terminator. And here's how some of our friends around the world are observing the moon.
Todos los años, a finales de octubre, hay una noche especial en España. Es una noche en la que decenas de asociaciones astronómicas sacan sus telescopios a la calle. Estamos hablando de la Noche de la Luna, cuando juntos todos comparten su pasión por el cielo.
Nazywam się Kinga Gruszecka i zapraszam do wspólnej obserwacji Księżyca.
Nosotras somos como la luna. Cada fase es un cambio para llegar a nuestra plenitud. ¡Viva la noche de observación lunar!
Hi, I'm Matt here at the South Pole Telescope, celebrating the moon.
みんなで月を見よう. I'm focusing on the moon because humans will be expanding the area of activity in the near future.
Hello everyone, we are the Gallagher choir from South Africa.
And we are so excited to be celebrating the International Observe the Moon Night with NASA!
Hi, I'm NASA astronaut Tracy Dyson, orbiting 260 miles above the Earth aboard the International Space Station. Tonight is time to come together to appreciate and observe our shared moon. We are blessed on the ISS to be able to observe the moon from space, being situated over the Earth's atmosphere. It's quite a sight to behold. The effect of the moon is most dramatic for us over large bodies of water. When the moon is full, it illuminates the whole surface of the Earth, and the ocean glistens with a beautiful soft glow. Contrast that with the new moon, and the oceans are as black as a starless universe. It's almost as if the Earth disappears. It's crazy. Wherever the moon is in its phase, when spotted, you can hear someone say from the cupola, "Come look at this moon." So my crewmates and I are excited to contribute to work that is stepping stone toward NASA's return to the moon through the Artemis program. Stay curious and keep looking up.
Yeah, so you just saw how folks around the world are observing the moon. But Andrea, do you have any tips for people to observe the moon? First, with a telescope, if they have one.
Sure. So if you're fortunate enough to have access to a telescope, there are some wonderful features to look for. We have moon maps that have lots of features identified, but something you might want to try is looking along the terminator, the line between day and night on the moon. It's the dawn and dusk line, just like here on Earth, and that's where the shadows are the longest, and so you can really see that rugged lunar terrain pop out.
It's really special to be able to do that. Definitely encourage you if you have a telescope. But if you don't have a telescope, you can still participate with the naked eye. What are some things you can look for if you're just looking at the moon?
Absolutely. So if you're looking up and you see those dark areas and those light areas, those are the 2 major types of rocks that we find on the moon. The highlands, the lunar highlands, the ancient rock, they're kind of bright. And the mare, these floods of basalt, are darker. So those are 2 things you'll definitely see. You might see some crater rays. Tycho crater is visible, and you can see some rays emanating from this little crater that's fairly fresh, and we know it's fairly fresh because of those bright rays. If you're not able to go outside to observe, you also can do different things. So right now you're watching this broadcast, of course. We also have telescope feeds from around the world on our website, on our live streams page, and you can really be creative. This is a moment that we're excited to have traditional observing, but there's also the opportunity to feel the moon with 3D prints of the lunar surface. You can taste the moon a little bit. You could make, moon phases out of chocolate sandwich cookies and try that out. You can listen to the moon. There's lots of moon songs, there's actually some lunar data that's sonified that you can listen to lunar data, or you can, listen to your favorite moon songs or moon movies or moon stories. This is a time to celebrate the moon in arts and culture, and we really encourage people to be creative with how they're observing the moon today.
So to learn more about how to observe our moon, we're joined by NASA data visualizer, Ernie Wright. How's it going, Ernie? Thanks so much for joining us.
It's going great. I'm very happy to be here.
Always good to bring you in for nights like these when we're looking at our nearest celestial neighbor, the moon. What gets you excited about looking at our moon?
Well, International Observe the Moon Night is this time for everybody to observe together, but I always think it's a good time to go out and look at the moon. I enjoy watching the phases change. It's like having a calendar in the sky. And I also enjoy, because I have telescopes and I'm an amateur astronomer, I enjoy watching the terrain change as the shadows play across it.
So this event always occurs when we have a near first quarter moon. It's a little bit of a bigger phase this year. So what are you going to be looking for tonight?
Yeah, so it's a waxing gibbous phase, which allows us to see some things in the western half of the moon that we normally don't see during this event. I'll be looking for Aristarchus Plateau, which is right on the terminator, that day-night line, because that throws a lot of the terrain right there into relief. Aristarchus Plateau is this sort of diamond-shaped volcanic feature that's lifted up above the rest of the surface, and you can really tell that when the shadows are long the way they are. You'll also be able to see more of Copernicus crater, which is in the middle of a mare, but it's very bright and it has all these rays, all these ejector rays. Just imagine the explosion that happened when that crater was formed to throw stuff out hundreds of kilometers in every direction.
So Ernie, today is a day that a lot of people will be maybe taking time to observe the moon. Who knows, perhaps for the first time, like really paying attention to the moon at all. And a lot of people are going to be looking through a telescope for the first time. We know that a lot of people do that today. So if you haven't been paying attention to this amazing, beautiful world near us, what are some things that we should look for, just out in our backyards? And then can you talk a little bit about what that experience might be like to look through a telescope?
Through a telescope. I think it will surprise a lot of people how amazing that view is. When my kids were in second grade, I would take a telescope up to the elementary school during the day because the third quarter moon is visible in the western sky. And all the kids would sort of line up and look through. It's a little difficult to sort of aim your eye right down the barrel of the eyepiece, so you may not see something right away, but I could always tell when the kids actually got lined up and saw it, because they'd all go, oh! They would make faces, they would gasp, they would get excited, they would start jumping up and down. So I think even the grown-ups will jump up and down on the inside when they look through a telescope for the first time at the moon and see how complicated and uniquely beautiful that surface is.
And we want to hear about your first experience. If this is your first time looking through a telescope, be sure to share that experience with us using that hashtag #ObserveTheMoon. And while we observe our nearest celestial neighbor here from Earth, we actually have one mission up in space getting an even closer look at the moon.
Since its launch in 2009, NASA's Lunar Reconnaissance Orbiter has been gathering incredible amounts of data about the moon. This information has led to many scientific discoveries, shedding light on the moon's history, composition, and potential for future exploration. One of the most heavily used instruments on LRO is its high-resolution camera system, which is able to capture incredibly detailed images of the lunar surface. By analyzing these images, scientists have been able to gain new insights into the moon's geology and its evolution. For example, LRO has provided new data on how the lunar surface changes as a result of the formation of impact craters. During its years orbiting the moon, LRO's camera has captured the immediate results of meteorite impacts on the surface, such as scattered debris and ejecta patterns on the surface. And since the moon lacks an atmosphere, these newly formed craters remain essentially untouched over many years, allowing LRO to continuously measure and collect data on them. This means scientists can analyze a crater formed a year ago and use it to learn about craters that formed millions or billions of years in the past, giving us clues about the moon's geologic history. We can't replicate this type of study on Mars or on Earth, since atmospheric conditions like wind are rapidly changing the surface. The moon is therefore a unique environment for learning about our solar system. Another major focus of LRO's mission has been the moon's south pole. This region is of particular interest to scientists because of the detection of water, which will be a vital resource for future missions to the moon. The data LRO has collected allows scientists to create detailed maps of the South Pole, leading to the discovery of large regions that appear to contain significant amounts of this water. These discoveries are important because they could help make future missions to the moon more sustainable. Instead of having to bring all their own water with them, astronauts could potentially extract water from the lunar soil and use it for drinking, cooking, and even rocket fuel. The Lunar Reconnaissance Orbiter spacecraft is also equipped with a suite of scientific instruments that aid in exploration, including a laser altimeter called LOLA that is able to measure the precise elevation of the lunar surface. Using LOLA, scientists have been able to create the most accurate map of the moon's topography to date, as well as improved lunar gravity models, both of which will help future exploration efforts. Finally, data from LRO has helped us better understand the composition of the lunar surface, shedding new light on the moon's history. The data has shown that a wider range of compositions of volcanic rocks exist on the lunar surface than previously thought. We have found compositions of rocks that are not part of the Apollo sample collection, and evidence for volcanic activity that may have occurred only 50 million years ago. That's 950 million years after scientists had previously thought it ended. This information helps us piece together a geologic history of the moon from just after its formation to the present day. Information that will aid in understanding future samples collected by Artemis astronauts. Thanks to the incredible data gathered by the Lunar Reconnaissance Orbiter, NASA and the scientific community are making incredible strides in our understanding of the moon. With every new discovery, we are one step closer to unlocking the secrets of our closest celestial neighbor.
So you just saw some of the ways in which NASA observes the moon, and so we're back here with Ernie to learn more about how data visualizers like himself use these data to create some incredible visualizations of the moon. So Ernie, so you get all this data back from LRO. I'm always curious to know what your approach is to kind of distill that down into the beautiful imagery that we see.
I feel so fortunate to be working with LRO data because this is the first time that we have complete global maps of the moon, including the shape of the surface, and that's what gives you those beautiful shadows. And that's kind of, the moon is this very stark landscape, and without the shadows, you don't have a whole lot to show. So I use all of these maps of the surface shape and the surface color, and I put the sun in the right place, and sometimes I put the camera where the Earth is, so far away with a big telephoto lens, like I'm looking through a telescope. And really, all I have to do is point at the moon, and there's so many beautiful things to see there.
Yeah, the resolution is crazy. Can you give us kind of a sense of scale, like as per pixel resolution that you're able
Yeah, so the cameras on LRO, there's a wide-angle camera that's 100 meters per pixel, and there's a narrow-angle camera that can get down to half a meter or even better. This is what has allowed us to take pictures of the landing sites of the Apollo astronauts. The descent stage of those landers is still there. We can't see the flags, but we can see the shadows that the flags cast. And we can see their footprints. We can see the tracks that they left, and we can see the rover tracks, and we know exactly where they went. We can see the rover. Apollo 15, 16, and 17 had a dune buggy that allowed them to travel for miles on the surface. And the other really important component for me is the laser altimeter. This is a laser that fires shots at the surface 28 times a second, and it has a clock in it that can time how long it takes that laser light to leave the spacecraft, hit the surface, and come back again. And we're talking about fractions of nanoseconds. But that tells you exactly the height of the surface that they're firing at. They've shot that laser over 10 billion times. And so we have maps of the shape of the terrain based on that are 60 meters per pixel near the equator and 5 meters per pixel at the poles. The advantage of a polar orbiter like LRO is that it goes over the pole lots and lots of times, and all of those tracks are squished together, so you get really high resolution there. And that's fortunate for us because we kind of want to land there at the South Pole. Yeah. And so we know the shape of that terrain better than any of the landing sites in Apollo, and it really helps with the planning.
Your mention of the South Pole, I mean, we are doing a lot to get ready to continue exploring the moon. We have been with LRO for a long time now. It's amazing how fantastic and long-lived the spacecraft is going, the little spacecraft that could.
Yes.
But we're also learning a lot with your visualizations. They're stunning. They're beautiful. This is like my favorite meeting, is learning what Ernie has created with this data that's a little bit hard to approach in raw format. But we're also benefiting as a science community from your visualizations. So can you talk a little bit about the types of mysteries you're helping to solve, the types of puzzles, the types of challenges that your work is helping us overcome as we're exploring the moon and learning about it?
I always think of myself as an artist with no talent, and so what I try to do is use the computer as my sort of talent aid, and my approach has always been the more realistic I can be in my rendering, the closer I can get to the beauty of nature. This is something that I don't have to work at. It just comes out of doing things that show what it really looks like. And so for deciding where to land when we go back, it's really important to get that illumination right. At the South Pole, the illumination is just bizarre. The sun is never more than 1.5 degrees above the surface, and so you get these gigantic long shadows that are cast from mountains that are over 100 kilometers away. If your spacecraft is powered with solar panels, you kind of need to know if you're going to be in shadow or not. So I hope that when I visualize the illumination at the South Pole, it's helping to choose the landing site and plan how we do our EVAs when the astronauts step out and explore the surface. Do they have to walk through shadow? Can we use Earthshine to sort of help in those situations? What is the big difference between summer and winter? You wouldn't think that the moon would have seasons as extreme as the Earth's, but if you're at the South Pole, it makes all the difference, whether the sun is 1.5 degrees above the horizon or 1.5 degrees below. So that's what I'm trying to do now is help people understand what that lighting situation is.
Yeah, and also I guess this work we were talking about is preparing the next generation of astronauts for Artemis. What does that mean to you that your work, your data is being used in this situation?
It's so cool. I have been sent pictures of astronauts in training who are looking at my visualizations and identifying features on the surface and understanding how changes in lighting make things more difficult. This is actually something that during International Observe the Moon Night you can see for yourself. On the eastern side of the moon, you'll see that the craters kind of disappear. What you see is the coloration, but because there aren't very many shadows there, you can't tell what the shapes are. And so I think it's helpful for the astronauts to see what everything looks like under different lighting conditions and how something that on a map you might say, I know exactly where that is, but if the illumination is different, you might not see it that way at all.
And you have such an incredible knowledge of all the features of the moon. I always wonder, what is a feature on it that kind of draws you back in every single time you see it when you're looking through this data?
Well, I've been staring at the moon for 15 years now, and you kind of have to. So I like unusual things like Reiner Gamma, which is this swirly feature. It's not a crater. It's not a shape on the surface. It's a coloration that we think is caused by local magnetic fields that sort of are redistributing dust particles. It's a little bit like the magnetic face that you can kind of draw mustaches with, that's happening on the surface of the moon, and we call those swirls. But Reiner Gamma is the most obvious one, and you can see that through an amateur telescope. In an amateur telescope, it looks like a little figure 8 that's drawn on the face of the moon.
Yeah, it's amazing you could see these in real time. I think of like the Shoemaker-Levy 9 impact on Jupiter. Is there anything that you've been able to capture in real time with LRO here at the moon?
Yeah, LRO is detecting a lot of meteor impacts, and I mean, we say meteor, that's kind of an Earth thing. It's the bright flash in the atmosphere, but there are also these particles that are hitting the moon and small boulders. And we have seen flashes on the Earth that indicate that an impact has occurred, and LRO can fly over that later and see a new crater. And because it's been there for 15 years, it has older pictures of that area. And so we can kind of do that two-frame GIF of craters there, craters not there. And you can see crater formation processes that are happening right now. In fact, I was surprised to learn that based on this, they call it the gardening rate. This is how fast the surface changes. That rate is probably 100 times faster than we thought it was. This has implications for the astronauts' footprints. We thought they would last 1 million years. They may only last 10,000 because there's still so much activity on the surface, right?
It is really incredible. LRO has helped us reshape our understanding of our nearest neighbor in space, and so much of your work has helped us understand what is going on. And there is a 15-year collection of Ernie's work helping us look at some of the neatest highlights, the greatest science results, and all kinds of beautiful areas that we can observe on the moon. So.
And it's been such a privilege to work on that data and actually see that happen and see scientists see things that they didn't see before. It's this time capsule of the formation and evolution of the entire solar system. So everything you learn about the moon tells you something about where we came from, where the Earth came from, where the rest of the solar system came from. And to see that understanding grow in real time based on LRO's data is really amazing.
And you've combined all of this data into, I think, in my opinion, and probably everyone's opinion at NASA's favorite video of yours, which is this one set to Clair de Lune by Debussy. Moonlight. It's a beautiful visualization, and we'll watch that now, and I encourage you all to just enjoy and take this one in.